Oh, let me go back to Teams. Oh yeah. How did I do that? I don't know how I did that. I've got too many ruddy windows open again. Right, let me try again. Oh, I know why. Because it went to the last folder I'd opened. You know when you do an upload, sometimes it remembers where you uploaded last time. And I just didn't look. What an idiot. There we go. Alright, that's the right one. Right, okay, I have actually uploaded the correct answers now, so stop what you're doing and let's have a look at this. Can't believe I did that. Right, okay, so if you get, one of the things that you'll get with all of the data structure questions that we'll do will be, they'll ask you for algorithms. So how would you add something, how would you remove something, how might you search for something in that data structure. But another thing they will ask you to do is to just, at a basic level, demonstrate that you understand how it works. Okay, so where we've got the stack, there isn't really much to a stack other than putting on and taking off, pushing and popping. So what they're going to expect you to be able to demonstrate is that you know that the order matters. So the order that the operations come in will determine how the data looks on the stack. It's the same thing when we do things like trees. We'll have the same situation where they'll give you data in a certain order, and actually the order that you provide the data shapes the tree, and you'll see that when we get onto tree structures and things. Okay, so it's really important that whenever you are doing stacks, you can keep writing down on top when you're adding things, but whenever you have to remove something, so you're going to get a mark, and I've put on the mark scheme what the marks are for. What colour pen have I got? Let's have a red. Go on. Right, so I'm pushing a J, so I can write that down. Well, let me zoom that. I can write that down if I want, and then I'm pushing an M. So that's fine as I go along, all right? But as soon as I take something off, don't start doing crossing out, because that's going to lead to disaster later on. All right? So what I recommend you do is whenever you remove something, or whether you've stopped removing, write out what the state of the stack is afterwards. So where we've got this pop, you know you're going to have, and yeah, you have got to write some stuff down and so on, but we're trying to make it clear so that we don't screw it up. So after you've popped, you should have had JRBQ. You're then going to push something, so we can just use the same one and put the Z on. I've separated this and colour coded it in the mark scheme so you can see it. Okay? Right. Don't mess about with editing the document. Alright, we haven't got time for messing about. Alright, if you want that, then that's fine, but I haven't got time for it, and it isn't amusing, and if there's enough people at this place who's incredibly stressed, don't add to it. Okay, have a little bit of a thought about outside your own little unique self as to the state of everybody else. Right, so we can push, but when we do the pops, we need to say, right, we'll pop in 3 things this time. So actually the state of the stack after that is just going to be Q and B. And then we've got a final push, so the final state of the stack should be that. Okay, so it's really important, don't start doing all this scribbling through. It's a disaster on the A level when we're manipulating data structures. Okay, so has everybody ruined that for everybody and edited the document and everything? Yeah. Right, okay, so it's all about clarity when we're demonstrating things. I've said it to you before, like when you're doing the binary, don't just spray binary values all over. Try and be clear. It might even be that you annotate things and you say like, oh, pushed, and you actually say pushed after pop and things like that, just so you're making it super clear for the examiner. Right, okay, so the meat that they're going to expect from you is writing the pseudocode. If they ask you to do a fragment of code, then nobody's going to expect parameters or function or procedure skeletons. But if they do say subroutine or they say function, then you're going to have to format this as a function. So if we just quickly look, there's no point in me typing this again. If we quickly look at how I award marks for this, so it says write a pseudocode subroutine for the push process. Ensure you consider errors. So you're not going to be asking the user to input, you're going to put a parameter. So what do you want me to put on the stack? I'll put it as a parameter. So they'll expect to see something where you say either procedure or subroutine, and you put a name, sensible name, username they're giving the question, so in this case push, and then a parameter with a suitable name. Don't just call it A or X or anything. I've called it item. We tend to, whenever we're messing with data structures, if we're talking about the data that's stored in the structure, we call it an item. Okay? But you can call it whatever you want. If there's a context in the question, use that. Okay, so you're going to get a mark for that. You're going to get a mark for your error checking. Okay, so I'm checking whatever method. Yes, Josh. No, I'll let you off for now, but you must really try and think about that. Naming is important. Sometimes they tend to be explicit if they say make it readable or maintainable, and then you know they're going to be nagging at you for the correct namings and sensible names. But if you've ever got in a question a specific name, let's say they're saying about a board game that uses a 2D array called checkerboard or something, they'd expect you to use checkerboard when you reference the array. Okay, right, so yeah, a check for making sure that you got a test to see if the stack was full. Going ahead, stuffing the item at the top of the stack, you get your mark. Making sure you increase the stack pointer, you're going to get a mark. You may have written that differently. You might have put SP plus equals 1. You might have put SP equals SP plus 1. They're all valid. Okay, and then the dreaded error message. As long as you indicate in the correct logical place where the error should be generated, that's what matters. Remember, this is pseudocode. It's not saying how to implement it. It depends on what system you've got. If you were doing this in JavaScript, you might throw an exception, because you can in JavaScript, or you might just output some junk to the console, or you might return a value. Sometimes you have functions that will return a Boolean to say whether it was successful or not. Can't always do that in every language because you need other facilities, and we'll talk about those in C#. Okay, so award up to 5 marks for those elements in your question. I'll ask you to tell me what you got in a minute. Right, so with the pop's a little bit more complicated because we can't cheat and do what we do in C# and just say, oh yeah, just either return something or throw an error. You've got to make sure you do it in an order. Okay? So when we're asked for a function, so again we start with a skeleton. Function skeleton, so that's just function and a name. We don't need any parameters because we just take what's on the top. Check, first of all, don't just go straight in there. Always check to make sure your stack's got something in it. So the stack is going to have an element in it if it is greater than 0, the stack pointer. Okay? So we check for that. And if that isn't the case, that's where we generate our logical error. We then need to make sure, because the stack point is pointing at the free space, that we drop it. Okay, again, you could write this multiple ways. You could have written, if I just load me whiteboard up quickly. No, that's the speaker. God, I can't see. Hang on, no, that one. Right, if I just load up a whiteboard and don't have it full screen, hang on. When it connects. Caught the top of the thing. Let's put that at the top. Let's get rid of that. Right, okay, where's my whiteboard? Right, so where I've got this bit of code here, where I'm saying SP minus minus, and then I've got item equals stack at the stack pointer, and then return. I could write that in a different way. I could have easily said item equals SP, oh, hang on, stack SP minus 1. I could have written that and then done SP minus minus. It doesn't really matter. Okay? As long as it's logically correct, that you get the top of the stack, however that is, and adjust the stack pointer. Okay? And then we return the item. So as long as the logic is okay. Right, so up to 6 for that, because it's a slightly more complicated process. You might find that they say you retrieve the top of stack and you only get a mark, but try and keep it separate. Don't try and be clever. Clever might be good for you, but it ain't good for an examiner who's not very comfortable with programming, unfortunately. Okay, a load of these things you could do in one line of code, but that's not going to get you the marks because they ain't going to understand it. Right, and then the last question. Purpose of a stack. Well, the ones that are fundamental, the hardware level ones, saving a program counter when an interrupt occurs. So at the end of the fetch execute cycle, if an interrupt is found, PC is saved. So we say, oh, let's remember where we were going to carry on, and we'll go off and do the interrupt. Same process when we call a subroutine or execute a subroutine, we save the PC. Storing a stack frame during a subroutine call. The stack frame is where everything ends up, and we'll look at this in a little bit more detail, and you'll see it more and more when we are debugging programs as well. Storing parameters, when you call a subroutine, they're pushed onto the stack in reverse order, and we'll look at that mechanism. Local variables, so whenever you're in a function and you create a local variable, actually it's dumped on the stack because it makes it easy to get rid of it, because you just change the stack pointer and it's gone, binned off. And then a couple more technical ones. Backtracking algorithms use the stack, so they remember where they got up to so they can go back and try another route. And then depth first search, which is one of the search methods we've got to look at. Okay, there are hundreds and hundreds of uses of stacks. Try and stick to core ones before you start going out on like airy-fairy. You use a stack when you're riding a unicycle round Hampton Court Maze or something, which you probably could use a stack for that, but probably not a good example. You're probably thrown with a unicycle. Anyone ride a unicycle? No. Anyone juggle? Because that. Nobody juggle? You're all good in my book. I don't like jugglers. There's something pretentious about juggling. It's an odd thing. Right, can you total that up, ladies and gents? That was out of 18, and let me know. Yeah, that's fair enough. Oh, but how many different places can I put things? I can't see, that's all. But
when I type my friends like Discord and I type so quickly, I end up making so many mistakes.
yeah, but that's the bane of everybody on social media, isn't it? Also, the worst one is you type something and then after you press enter, it decides to auto-correct a word and change it completely, which they do all the time, the stupid keyboard. Well, Callum got 17, that was good. Right, let me find my spreadsheet. Where's my tab? Where's my tab? Right, okay. Right, so this is the second stack quiz we've done. So we'll get an aggregate score for this. Right, hang on. I'm going to have to lock me first. Right, Grace, what do we get? 17, good. It's another one of these things where you've never heard of a stack, but actually it sounds complicated, but actually it's ridiculously simple. Jacob, 16. James, this is better than last time for everybody. Nathaniel, excellent. 5 house points for full marks, remember. Josh, if I remember, 18 it was ours. You got 16, yeah. Amalek, 13. Hurry up, 16. Ralph, 14. Joe, 14. These are better than last time. Hugh, 14. Harvey, 16. Ollie, 16. Common number, that one. Dan, 14. Theo, 18. Well done. Zan, 14. Zach, where's he gone? 15. Yeah, no, it's because I tend to look that way. Callum got 17. Matt, 18. Well done. Henry, ooh, so close, 17. So close, but you get nothing. Nobody remembers second place, do they? They do say that. And Seth, 16. Right, okay, excellent everyone. That was millions times better than last time. We will, in the future, come back to stack. Okay, right, next week, I think I've put all this information on there. Let me just double check. Right, listen up just before you get going. Right, so next week the test will be cues. A little bit more complicated cues. We've got 2 points to worry about, remember, and a couple of different ways they can be set up. Okay, after that, your task on Monday, I've decided, is not going to be a debate. You're going to teach yourselves all about linked lists. Oh yes. Yes, you are. Linked lists. Really fundamental data structure. There are 2 methods. So in the computer endorphin section, I have put this information. So I have given you 3 vids that I've done that are about linked lists. For some unknown reason, the second one didn't do a preview. I don't know why. The link's there, but it didn't preview. So there's 2 videos that go through static linked lists, and then there's a 3rd video that goes through dynamic linked lists. Okay, dynamic linked lists is how we use them. Static is how the example test a lot of the time. So they are handy to use. I've written machine code programs that use static linked lists, so you can manage it and stuff. But we'll talk about all this the Monday after. Okay, Wednesday's lesson will be finishing the stack and you trying to do a queue. Okay, based on what we've done about queues and all that. Right, okay, thank you everyone. I'll end the sesh there, and Callum can have a go at doing some Google stuff or setting up his Visual Studio. How do I get out of this bloody meeting? Oh, the interface on Teams is terrible. I'm in the meeting, but I'm not in the meeting. Right. End meeting. Utter jump. Yes. Oh yeah. That's when I was allowed to wear jeans and t-shirts. If you look at my older videos, you'll see that I don't wear suits. If I did it my way, I would say that my business outfit should be t-shirt and jeans. But I did try, but no one cares. But there you go. Tech don't wear suits, do they? It's cash.